Good morning, friends. Here we are talking about the next topic of the unit 3 of the paper 1, that is the thermodynamics. Here we have to see what is the thermodynamics. This concern with the transformation of heat into mechanical work. It deals with the concept of the heat, temperature and interconversion of the heat into other forms of energy, that is the electrical, mechanical, chemical, magnetic. Thermodynamics does not take any account of atomic or molecular constitution of matter. It deals with the bulk system. Okay. Thermodynamics variables behavior of the atoms or molecular thermal system. State of any thermal system can be described in terms of certain known microscopic variables called as the thermodynamics variable. It may come for the MCQ. Okay, thermodynamic variables determine the thermodynamic behavior of the system. Quantities like the pressure, volume, temperature are the thermodynamic variables. Some other thermodynamic variables are the entropy, internal energy, extrinsic energy, described in terms of the pressure, volume, and temperature. Thermodynamic system is said to be in thermal equilibrium if all the parts or it are at same temperature. The two systems are said to be in thermal equilibrium if they are at the same temperature. Zeroth Law of Thermodynamics. Thermal equilibrium condition is defined as a situation in which no heat flows from one body to another when brought in contact with each other. You can see here system 1, system 2, system 3 are there. Okay. To know about the temperature, that zeroth law of thermodynamics is come. Heat exchange takes place between the two bodies till their temperature becomes equal. This condition is called thermal equilibrium, that you have to remember. It may come for the MCQ. Zeroth law of thermodynamics, if two systems 1 and 2 are separately in thermal equilibrium with third system 3, then they must be in thermal equilibrium with each other. Here the that consider if the system 1 and 2 in thermal equilibrium, that time T1 is equal to T2. Since system 3 and 2 are in the thermal equilibrium, 3 is equal to T2. From above this equation, we can compare that T1 is in equilibrium with T3, that is the system 1 and 3 are in thermal equilibrium. Concept of heat and the thermal interaction. Heat is energy, or more precisely transfer of thermal energy. As energy, heat is measured in watts, while temperature is measured in degrees Celsius or Kelvin. The words hot and cold only make the sense on the relative basis. Whenever the two independent systems in contact, thermal energy travels from hot system to cold system. Hot system heat up cold system. The cold system cool down hot system. The transfer of thermal energy takes place from something that is hot and something that is cold till the equilibrium is reached. Once the temperature of the both the system reach equal, that is equilibrium condition, then there is no net heat flow of heat between the hot and the cold system. Heat energy flows from system at higher temperature to one at a lower temperature only due to temperature difference. In the subject of heat transfer, such transitory form of energy are called heat. Transitory form of energy is called as the heat, that you have to remember. That may come for the MCQ. Whenever two independent systems are in contact with each other, that permits heat exchange between the system without transfer of mass across the boundary of system. If no net heat can flow into or out of the system, is called as adiabatic or thermally insulated system. When heat energy transfer between the two systems, that make if no heat can flow in or out of the system, is called as adiabatic or thermally insulated system. That come for the MCQs. When heat energy transfer between two systems, the temperature of the system rises, that system is considered positive. When the heat energy flows out of system, it is considered negative. That may come for the MCQ. Adiabatic interaction, the process in which no heat enters or leaves the system, is called as adiabatic process. For every adiabatic process, dq is equal to 0. That you have to remember. It may come for the MCQ. Okay. Magnetic work. Thermodynamics is not just about the ideal gases, pressure, volume, etc. It is very general. Let us demonstrate that by an important example, paramagnetic solid. Hmm? Work is equal to, here the one gas is, let us consider the work done by the gas. Here the magnetic work. Consider a adiabatic system of paramagnetic solid. When the system is placed inside the magnetic field, paramagnetic solid gets magnetized and its temperature increases. This increase in temperature is due to flow of energy into the system because of the work done by an external magnetic field, which is called as a magnetic field. It's called as a magnetic work. That definition of the magnetic work is mechanical work is given by. For that purpose, we have to consider work done by the gas enclosing a cylinder fitted with a piston capable of moving without friction as shown in the figure. If the pressure P of the gas is greater than the pressure outside, a net force will exerted on the piston by the gas. As a result of this force, let us assume that the piston has moved by an infinitesimal distance dx. The work done by the gas on the piston is given by dw is equal to force exerted by the gas into distance moved. dw is equal to pa into dx, where a is the area of the cross section of the piston. That all these things are. That's why dw is equal to p delta dv, and when you integrate, you will get a w is equal to integration a to b from p dv, is called as the mechanical work. This work done is negative because the displacement is in opposite direction to the pressure. For the infinite distance moved by the piston, it is integrated from the initial position A to final position B. Then thermodynamics interaction of the hydrostatic system. Isotropic or homogeneous system of constant mass and a constant composition that exerts the uniform hydrostatic pressure on the surrounding in the absence of the gravitational, electrical and magnetic effect. It called as the hydrostatic system. It may come for the MCQ. State of the system is defined by the pressure, volume and temperature. Such a system is also called as the PVT system, that you have to remember. Generally, hydrostatic systems are divided into following categories: a pure substance, which is a single compound in the form of the solid, liquid, gas mixture of any two, or mixture of all three. Homogeneous mixture of a different compounds, such as mixture of inert gases, mixture of chemically active gases, mixture of the liquid or solution. A heterogeneous mixture, such as mixture of different gases in contact with the mixture of the different liquid. The state of equilibrium of hydrostatic system of a single phase can be described in equation of the state by the three coordinates, namely pressure, volume and a temperature. Every hydrostatic, that is a PVT system, has an equation of the state expression relation among these condition that is valid for the equilibrium state. That is the ideal gas equation. PV is equal to RT for the 1 mole, where R is the gas constant and N is the number of moles of the perfect gas. PV is equal to nRT. General form of equation of the state for the hydrostatic system is equal to function of PVT is equal to 0. Now you can apply it for the that work. A thermodynamic process is any process that involves heat energy moving within the system or between the system. That is called as a thermodynamic process. It may come for the MCQ. Isobaric change, that the pressure of the system remains constant, is called as the isobaric change. Isochoric volume of the system remains constant, is called as the isochoric change. Isothermal change is one where the temperature of the system remains constant during the interaction of other system. Adiabatic change, there no heat is allowed to enter the system or leave the heat from the system, is called as the adiabatic change. Okay. Part dependence of the work. The work done by the system depends not only the initial and the final state but also on the intermediate state, that is on the path. Work is part dependent function that may come for the MCQ. Then internal energy and the first law of thermodynamics, that we have to talk about the internal energy and the first law of thermodynamics.